Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss some basic formulae and concepts. We'll be covering digital root concept. The concept is a fantastic mathematical concept. It is actually very useful in the case of competitive examinations when you wish to eliminate the options or when you wish to go for backward approach. Okay, and we'll be covering algebraic formulae, arithmetic formulae, and BODMAS. Okay, the application of all these concepts and formulae will be covering in the very next session. So let's begin today's session. Now, let's see what the term digital sum means. Okay, digital sum is, suppose I'm having a number say 1673. Digital sum or digital root of this number is actually the addition of all the digits. It will be 1 plus 6 plus 7 plus 3. So it is 7 plus 3 10 plus 6 16 and 1 17. Further 1 plus 7 8. So 8 is the digital root, or you can say digital sum of 1673. So this concept is actually very useful in the competitive examinations when you wish to eliminate the options. What happens, friends, whatever the calculation you have been given, suppose you are given 13 plus 14 and if it is 27, the digital root of left hand side is always equal to the digital root of right hand side. You know the left hand side, you know the digital root of left hand side, then you can choose the option which match to the digital root of this expression. Here let's match 1 plus 3 it is 4 and 4 plus 1 it is 5. So the digital root of LHS, yeah, that is left hand side is 9, and similarly the digital root of right hand side is also 9, that is 2 plus 7. So it matches. Okay, let's take more examples. Suppose I am having a multiplication that is 13 into 14. Exactly 13 into 14 is 182. Let's match the digital root. 1 plus 3 is 4 into 4 plus 1 is 5. If there is a multiplication sign over here, we'll be multiplying the same, the digital roots, and if it is addition sign over here, we'll be adding the digital roots. Okay, so it's 4 into 5, 20, and the final digital root is 2. Now let's see what's there in 182. It's 1 plus 8, 9, 9 plus 2, 11, 11, that is 1 plus 1, further we are getting 2. So we see the digital root of both the side is same. One more help is there. See, in this case we are getting 1 plus 8, that is 9. Whatever you are adding in 9, you'll be getting the same number once again. So further no need to add 9 while you are finding the digital root. In this case, suppose I'm not adding 9, that is 1 plus 8. If I'm not adding 9, so I'll be still getting 2. So the digital root of the number which is containing 9 can be found by deducting even 9 also. Suppose I am having 92, the digital root will be 2 only. Don't have to add 9 plus 2, then it is 11, then 1 plus 1 it is 2. Okay, suppose I am having 375, then digital root will be 7 plus 5, 12, and 3, 15, that is 6. Okay friends, and you can even skip 9s, as in this example 4, 5, 7, 3, 2, 7. I deduct 9, what I'm getting is 10, that is further 1 more than 9. So the digital root of this, that is 4, 5, 7, 3, 2, 7 is 1. It's as simple as that. Okay, we'll be using this concept in multiple choice questions. Okay, let's do 1 or 2 more examples. Now let's see this example. In this case we have to find 360 into 17. So let's find the digital root first of all. 360 is actually 9 into 7 plus 1, that is 8. If anything is multiplied by 8, if anything is multiplied by 9, the digital root of the product will be 9 only. Since 9 into 8, 72, the digital root will be 9 only. So we just have to check from the options where the digital root is 9. In this case 5, 6, 7, 8. It cannot be the right choice. Here 5, 6, 7, 8, 9, 10. Even it cannot be the right choice here. 6, 7, 8, 9. This can be the right choice, but let's check the another option also. Maybe there are two nines, then we have to go for one more step. So in this case 6, 7, 8, 9, 10. So still it is not the right choice. So we are left with 6120. None of the options is having 9 as the digital root except 6120. So the correct answer to the problem is 6120. So we can do the problems quickly, we can eliminate the options quickly if we are clear about the concept. We'll be applying the same concept while calculating the bigger numbers. As such, these sort of small problems can be done even without paperwork and so on, right? Okay. Friends, we have already discussed about rational numbers in our types of numbers session. Friends, there are two types of rational numbers. One is terminating decimals and other is non-terminating repeating decimals. Here we see the case of 5 by 8. In case of 5 by 8, if we divide 5 by 8 and after a finite number of steps, the remainder becomes 0. Such a decimal expression is known as terminating decimals. But in case of 14 by 11, we notice that the remainders repeat after a certain stage. Here 27 is being repeated, that is 27 is being repeated infinite number of times. Or we can say we have repeated block of digits in the quotient. So we say that this expansion is actually non-terminating or recurring decimals. Okay, we are asked questions on the basis of rational numbers to convert them to from decimals to fractions. So from for this sort of examples can be converted very easily. We can do it manually, but for this we have to follow some algebra, some techniques. Let's see one or two problems to elaborate this. Friends, this sort of number, that is 1.2727, we can write them as 1.27 bar. This bar represents the block which is being repeated for infinite number of times. Okay, so if in exam if it is written like this, then you have to assume that it is 1.272727 till infinity. Okay, let's do one problem. Suppose I have a number that is 0.4 bar. I take it as x. Now x is 0.4 bar, that means x is 0.4444 and the series go on. Okay. Now let me multiply both the sides with 10. So 10x will be 4.4444 and so on. Let me take it as step 1 and let me take it step 2. Now I can deduct the step 1, the expression is step 1 from step 2. So 10x minus x, what I'll be getting is 9x and 4.4444. After decimal there is an infinite series of 4. So from this infinite series of 4, this infinite series of 4 will get cancelled. So I'll be getting just 4. So x is equal to 4 by 9. That means if you are going to divide 4 by 9, you'll be getting 0.44444 and so on. So it's very easy, friends. Okay, let me take one or two more examples. Suppose I have a number, say x is 0.32 bar. That means x is equal to 0.323232. Let me multiply both the sides with 10. 10x will be 3.23232. Here I observe the numbers after decimal or the block of numbers after decimal is not same in these two cases. So let me multiply 10x by 10 once more. So it's 100x is equal to 32.3232. So now we compare these two. Here it is 100x, here it is x, and the numbers or the block of numbers after decimal is same. Okay, so I can deduct this x from this 100x from both the sides. So 100x minus x is 99x is equal to 32. Since the numbers after decimal will get cancelled, so x is equal to 32 by 99. So We can draw a conclusion from both these examples that as many no, digits are there which are being repeated, as many nines will be, those many nines will be there. Okay. So suppose I take one more example. Suppose x is equal to 0.23 bar. Then it will be definitely 23 by 99. No need to calculate. Suppose I have x is equal to 0.57 bar. So it will be 57 by 99. Suppose I have x is equal to 0.235 bar. Then it will be 235 by 999. No need to calculate. Okay, friends? Now suppose I have a number, say x is equal to 0.235 bar. Here I am having bar on 35 only. That means only 35 is being repeated. 235, 35, 35. Now I wish to convert this expression or this rational number into a fraction. So what will be my first step? Let's begin. It's 10x is equal to 2.353535. Now 100x is equal to 23.535353. Okay. Now I'm not getting a sequence where the number or the series of the number after decimal is same. So let me multiply it one more time. 1000x will be 235.353535 and so on. Now we can make the comparison between these two. The series after decimal in both these cases is same. So let me deduct 10x from 1000x. What I'll be getting is 990x, and that is 235 minus 2. And the series after decimal will get cancelled. So x is equal to 235 minus 2 is 233 by 990. It's very simple, friends. Okay, let's do one more problem. Now suppose I have a number x is equal to 0.235, but this time the bar is only on 5. So what this number will be 235555. Okay, let it be x. Now what 10x will be? 10x is 2.35555. 100x will be 23.555. 1000x will be 235.55. Okay, still I'm not getting the sequence. I have got the sequence same in these two cases. Here it is 23.555, here it is 235.555. So what I can do is I can deduct 100 from 1000. So 100, if I deduct from 1000, what I'll be getting is 900x. And here it is 235 minus 23. So what it will be? 5 minus 3, 2. 23 minus 2, it's 21. So x will be 212 by 900. Okay, friends. Friends, now let's make a comparison among these three cases. Here I am having bar on 35. So and here I am having bar on 5 only. Here I am having bar on 235. So it's we can draw a conclusion over here that here I am having bar on 2 digits. I am getting 2 nines over here. Here I am getting bar on 1 digit. I am getting 1 9 over here. Here I am getting having bar on 3 digits. I am getting 3 nines over here. So as many digits having bar will be getting those many nines. Similarly, I am having one digit with without bar, so I'll be putting 10 over here. Here I am having two digits without bar, so I'll be putting 2 zeros, and here I'll be having no digit without bar, so I'll not be putting any zeros. So if you can memorize this concept, it will be very easy for you to tackle this sort of questions in your examination. You won't be taking much time to solve this sort of problems. So it is 235, that is the complete number, minus number or a digit which is having no bar. Here 235 minus 23, that is the complete number, minus the digits having no bars. Okay, so it's very simple to do. Okay friends, I hope you are clear with the problem. Now let's do this problem quickly. It's 2.612 bar, so it will be 2 plus 612 by 999. Three digits are having bar, so I am putting 3 nines over here. Similarly, it is 2 plus 612 minus 6 over 9, 9 and 0. Okay, similarly in this case 2 plus 612 minus 61 over 900. Now suppose I am having one more number 23.56 maybe 56 bar. So what I can write is 23 plus 56 by 99. Suppose I am having 23.56 bar on 6 only. So what I'll be writing is 23 plus 56 minus 5 over 9 for 6 and 0 for this 5. Okay, I can take one more example. Just a moment. Suppose I am having 0.512 bar. So it will be 0.512 minus 5 upon 990. Now if it is 0.512 bar like this, then I'll be having 512 minus 51 over 9 for this 2 and 2 zeros for 51. So it's 900. Okay. If you can memorize the concept, it will be really very easy and useful for you to do this sort of question in your entrance examinations. Okay friends, I hope you are clear with the concept. Now we see some important expansions which will be useful when we are going to solve multiple choice questions. See this first expansion, x plus a into x plus b is equal to x square plus a plus b x plus ab. This is actually polynomial multiplication which you might have learned in your junior classes also. So just for a recap, I'm just going to share it with you. Here it's a plus b whole square, that is a square plus 2ab plus b square. Okay, and a minus b whole square is equal to a square minus 2ab plus b square. Here a plus b whole cube is a cube plus 3ab a plus b cube. A cube plus b cube is a plus b a square plus b square minus ab. Here you can see a plus b is a factor of a cube plus b cube. Friends, sometimes we are asked a question based on this concept or this formula. So we just have to keep this thing in our mind that if a is having any odd power plus b is having the same odd power, that is a raised to n plus b raised to n is there, where n is an odd number, then definitely a plus b is a factor of the expression. Okay, and if a raised to n plus b raised to n is there, and if n is even number, then a plus b will never be a factor. A plus b is not a factor. Okay, so this will be this concept will be useful while we are dealing with the MCQ questions, multiple choice pattern questions. Now let's see, it's a minus b whole cube is a cube minus 3ab a minus b minus b cube. Okay friends, let's see more concepts. Here a cube minus b cube is equal to a minus b a square plus b square plus ab. That means a minus b is a factor of a cube minus b cube. Similarly, if a raised to n minus b raised to n is there, if n is odd number, any odd number here I mean is a positive integer. Okay, so then a minus b will be definitely a factor of an minus bn if n is odd number. Similarly, here we can see a square minus b square is a plus b into a minus b. So if an minus bn is there and if n is even number, then a minus b and a plus b, both of them will definitely be a factor of a raised to n minus b raised to n. So if n is even, a minus b and a plus b, both of them will be a factor, and if n is odd, only m minus b will be a factor. Okay, similarly a plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. You have to memorize this formula. Okay friends. Now, in this case, a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. In this case, we can observe that the factor of left hand side is a plus b plus c. So if a plus b plus c is 0, the entire right hand side will be 0. In that case, we are left with a cube plus b cube plus c cube minus 3abc as 0. That is a cube plus b cube plus c cube minus 3abc as 0. That means a cube plus b cube plus c cube will be 3abc if a plus b plus c is equal to 0. Okay friends, so this concept or this formula can be used various times, in various questions. So we'll be covering the same in our problem solving sessions. Let's discuss the next formula. As we know, dividend is equal to divisor into quotient plus remainder. We'll be using the same while solving multiple choice questions. Here we have been given the sum of first n natural number, that is 1 plus 2 plus 3 till n, and the formula behind that is n plus 1 by 2. You should memorize this formula so it will be easy for you to solve the problems. Similarly, the first n natural numbers, that is square of first n natural numbers, that is 1 square plus 2 square plus 3 square till n square will be getting as n plus 1, 2n plus 1 by 6. Similarly, cubes, 1 cube plus 2 cube plus 3 cube. So we should memorize the formula n square n plus 1 whole square by 4. Now what the BODMAS rule is there. This rule says the correct sequence in which the operations are to be executed, so as to find the value of a given expression. B stands for bracket, O stands for of, D for division, multiplication, addition and subtraction. We should execute the mathematical expression in the same order only, else we'll be getting the wrong answers. So we'll be taking some problems on the topics. Let's meet in the next session.